Hi guys, so today we are going to solve a root locus problem. So the question has given us a simplified open loop transfer function, which is this, and a unity feedback control system, which is this. So we can draw the block diagram as this. So okay. So this is open loop transfer function with a unity feedback control. Okay, so to solve the root locus problem, we only use the open loop transfer function, which is this. So we simply put the numerator, which is this numerator, and denominator. So we put this numerator and denominator into the coding. So numerator, according to the question, is 1, while for the denominator is s plus 1, s plus 4. Sorry, s plus 2. Okay, we put the multiplication over here and close the bracket and use the function sim to poly. Alright, so then we run this program. Change folder. Okay, so we got the root locus plot over here. Okay, so let's see the question. So for the first question, we need to sketch the root locus. So the MATLAB system has sketched for us. So we can say for the question 1, MATLAB. So for the second question, determine the maximum value of k for the system becomes stable. To ensure the system becomes stable, the root locus must be on the left side of the imaginary axis. So if any of root locus passes through the imaginary axis, it becomes unstable. So we can zoom in on the line of imaginary axis. Okay, how we want to determine whether the line is already intercept with the imaginary axis, simply by looking at the pole, which is it changed from positive to negative. So we slide it a bit, so the pole become from negative to positive, so it has intercept with the imaginary axis. So at that point the gain is 48. So from the graph we know that the maximum value of k is 48. Okay, next question, it asks about the frequency of oscillation at the system at maximum value of k. So by referring to the graph, the frequency of oscillation of the system at maximum value of k is 2.83 radian per second. Okay, so for the last question, it asks about the value of k, so that the dominant pair of complete poles of the system has damping ratio of 0.5. So we refer again to the graph. So the line of damping ratio is over here. 0.76, 0.62, 0.48. So the damping ratio of 0.5 is lies somewhere between 0.62 and 0.48. Okay, so we want to know the value of K, so we simply zoom in over here. Okay, we can see the 0.5 is somewhere over here, so we can zoom in more. We just click again on the root locus graph and slide it through until the damping ratio is 0.5. Okay, so it's stated on this graph that gain on the damping ratio of 0.5 if is 8.3. So the last answer is value of K is 8.3. Okay, that's all. Thank you for watching.